Hello, I will be discussing another example on Ex2. For this example, it's simpler, it does not have any switches. I have a voltage source, independent one, a resistor which has a current IC, another resistor IX, and then a dependent source. The question says solve for IX, so I want to find IX when the 2-volt source, which is this one, supplies a 2 over 3 watt of power. Now, do you recall the relationship between the power and the voltage? Yep. We said the first video the power equals I times R. Now, if I have the volt and the power, so I'm missing only the current, I can find the current, right? So I'm going to say P equal V times I. P, he just said 2 over 3 watts equal the voltage is 2 times IC. Now, if I have uh, this equation, I need IC, so you go ahead and divide over the coefficient of IC because I want it just IC, so I divide over 2 and this is erased, and here you divide over 2, it's like you multiply the denominator on the other side by 2. 2 and 2 will be uh, taken off, and then 1 over 3 ampere. This means IC equal 1 over 3 ampere. Okay, why did I say IC? The current here is not IC, this is the current IC. But bear in mind that here it's the wire, the current would go this way, would go through the voltage source, would go through the resistor without splitting. That means the current IC is the same current as the current go through the 2-volt source. So I use this information, the power, to find the current here, which also indicates the IC, the current IC equals to 1 over 3 ampere. Now, if I'm having this current IC equals 1 over 3 ampere, he asked me for IX, so why did I find IC? If you find IC, then you can find the value of the dependent source. I always say, if you looked at this circuit, I know that he gave me some information about the power, so I used it right away. But if you don't know from where to start and you find a dependent source in the circuit, always when your eyes fall or when your eye falls on a dependent source, always search for the location of the current or voltage written on that dependent source. In this case, the IC. So I located the IC, and then I found the IC, which is 1 over 3 ampere. Now I go and find the value of the voltage source. 4 times 1 over 3 is 4 over 3 volts. Okay, so this we did it already. Now if I know the voltage here, would it help me to find the current IX? At this point, I'm gonna go and make sure that I named all nodes. This is node A, here is node B, and under here is node C. So I have 3 nodes. If you look at this voltage source, it has the letters BC. How about this resistor, BC? Since they're sharing the same nodes, we said they are parallel. The parallel mean they have the same voltage. If this voltage is 4 over 3 volt, this means that this resistor has the voltage of 4 over 3. Now, since you know the voltage and the resistor, you go ahead and find the current. Why did I put the positive and negative sign up and down? Since those parallel, they share the same voltage and they share the same polarity. The positive toward node B, here the positive toward node B, negative toward C. Now, since the current is moving from a high to a low potential, is this correct? Is this ring any bell? Yes, it says that this resistor is absorbing power, moving the current from, or a the current is moving from a high to a low potential, and this is correct. So I would anticipate the current would have a positive sign. So it's correct, it has the correct direction. So Ix equal V over R. The voltage is 4 over 3 since it's parallel with this, and then the current, the resistor is 6 ohm. 4 over 3 divided by 6, it will give you 2 over 9 ampere. And a positive sign for that, and this is the end of this video. It's easy. I would advise you to go ahead and solve those problems without looking at my notes, and then go ahead and solve the problem that I'm gonna give you for you to solve. Good luck guys in this quiz too, and then we'll see you next time. I'm gonna take for next video, I will be discussing the third module, or the third part of this uh, course. It would be talking about Kirchhoff law, and as we know it has two types. One involves the currents and one involves the voltage. So stay with us. Kirchhoff laws are very important, and you will see it through most of the sessions that we will discuss later on. Bye.